All right, complex numbers and roots, section 5.5, second day. All right, so today we're going to work more on solving quadratic equations with complex roots. Now, the nice thing about finding complex zeros of quadratic functions is it's exactly like completing the square. Just when we get to the end, you have to deal with the negative square roots. So you already know this process. You were already quizzed on this process. So make sure you know that process to be successful at this one. All right, so side equation equal to 0. So instead of g of x, x squared plus 4x plus 12 equals 0. So step 2, collect all the variable terms on one side, constant term on the other. So for this example, we're going to subtract 12 from both sides. Now you just need to set it up to complete the square. So you need to add the empty box to the end of both sides. Fourth step, find b over 2, the quantity squared. So b is 4, so I'm going to plug in 4. 4 divided by 2 is 2. 2 squared is 4. So I'm going to replace the empty boxes with 4s on both sides. I now need to simplify. In order to do that, I'm just taking negative 12 and adding 4 to it. When I do that, I get negative 8. Next step, factor the perfect square trinomial. Remember, completing the square always makes a perfect square trinomial. The way that we factored a perfect square trinomial: square root of the first term, sine of the second term, square root of the third term. So in doing that, I get x plus 2 to the quantity squared equals negative 8. To finish solving it, I need to take the square root of both sides. In doing that, I get x plus 2 equals positive or negative square root of negative 8. Okay? From here, you just need to finish solving for x. Okay? So in order to do that, I need to subtract 2 from both sides. Now the only place that this is going to be different is now I have a square root of a negative number inside. So when I go to break down the square root of negative 8, right, the product property is the square root of 4 times the square root of 2 times the square root of negative 1. Okay, 4 times 2 is 8. 8 times negative 1 is negative 8. And simplify everything from there. Square root of 4 simplifies to 2. Square root of negative 1 simplifies to I. So I have x equals negative 2 plus or minus 2i times the square root of 2. Right? And you can rewrite it as the two separate solutions of minus 2i and plus 2i. All right, so if that wasn't enough, we'll do another one for you. All right, so find the zeros of a function given g of x equals x squared plus 10x plus 26. Now, follow the exact same steps. Step 1, set equations equal to 0. So replace g of x with 0. Step 2, collect the variable terms of one side. So I'm going to subtract 26 from both sides. Step 3, set it up to complete the square. That means I need to add the empty boxes to the end of both sides. I now need to figure out what goes in the box by doing that. B divided by 2, the quantity squared. Plug in b. B is 10. 10 divided by 2 is 5. 5 squared is 25. So I replaced 25 into both my equations, both sides of my equation, and simplify. Negative 26 plus 25 is negative 1. My next step is going to be factor the perfect square trinomial. Yet again, reminder, anytime you're completing the square, you are making a perfect square trinomial. Square root of the first term, sine of the second term, square root of the third term. So doing that, I get x plus 5, the quantity squared, equals negative 1. Take the square root of both sides. I need to find out what x equals. So I have to undo the square root on the left. The only way to do that, square root both sides. Square root of x plus 5, the quantity squared, is just x plus 5. The square root of negative 1 is positive negative square root of 1. Now we just need to finish solving for x and then simplifying. So I need to subtract 5 from both sides. In doing that, I know that the square root of negative 1 is equal to I. So my answer is x equals -5 plus or minus I. Or you can break it down into both parts, -5 plus I and -5 minus I. So now that I did 2 for you, there's 1 for you to do for me. The last thing that we need to talk about is complex conjugate. Okay? Complex conjugate, right? A minus b times I is the complex conjugate of a plus b times I. All right? We're going to work on finding the complex conjugate. So if I have a plus 5 times I, or 5I, my first step, I'm going to write it as a plus b times I, or bi, which is a plus 5I. Second step, you need to find its complex conjugate, 8 minus a minus bi. So in order of doing that, I just replace the a and the b. So I get 8 minus 5i. Now you're done. Let's look at another one. 6i. I need to find the complex conjugate of 6i, or 6 times I. First step, write it as a plus b times I. I don't have an a value, so that is going to be 0. So it's 0 plus 6 times I. Find its complex conjugate, which is a minus b times I. So replace a and b. I get 0 minus 6 times I, which is just -6i. But we're not done there yet. Let's look at another one. 9 minus I. Step 1. Write it as a plus b times I. In order to do that, it's 9 plus -I. Find a minus bi, so replace a and b. Okay, so 9 and -1. So you get 9 minus a -I, which simplified is 9 plus I. But we're not done there yet either. We're going for another one. And -8 times I. Step 1, write it as a plus b times I. There is no a, so that's going to be 0. And I'm going to add -8 times I. Now, step 2, find a minus b times I to replace a and b. And you get 0 minus -8 times I. Simplified is just 8i. Now it's your turn. Have fun.